Impact Report projected 30% economic growth in aerospace, robotics, and renewable energy sectors by 2035. Date: January 28, 2025. Overview. The aerospace, robotics, and renewable energy sectors are on the brink of transformative economic growth, projected to reach a combined value of $1.8 trillion by 2035, up from $630 billion in 2023. This surge is driven by advancements in Mars colonization technologies, increased investment in international collaboration initiatives, resulting in an average annual growth rate of 9%. The implications of this growth extend beyond traditional boundaries, influencing various sectors and contributing to global challenges. Key findings. 1. Economic growth and integration. The World Economic Forum, WEF, and McKinsey & Company have highlighted the evolution of the space economy from a niche industry to a vital component of the global economy. A significant portion of this growth, over 60%, is expected to stem from the integration of space technologies into terrestrial industries such as supply chain management, transportation, food and beverage, state-sponsored defense, retail, and digital communications. 2. Technological advances and cost reductions. The number of satellites launched annually has increased at a cumulative rate exceeding 50% since 2019. Furthermore, launch costs have decreased tenfold over the past 2 decades, paving the way for more frequent and affordable space missions. Anticipated reductions in data costs, projected to drop by 10% by 2034, will further stimulate demand, expected to rise by 60%. 3. Impact beyond the space sector. The influence of the space economy transcends traditional aerospace industries, impacting agriculture, information technology, insurance, and construction. Space technologies are crucial for addressing global challenges such as climate monitoring, disaster management, and humanitarian efforts. 4. Investment landscape. Private sector investments in space have reached unprecedented levels, totaling approximately $70 billion in 2021 and 2022. The burgeoning field of space tourism, previously seen as speculative, is forecasted to generate revenues between $4 to $6 billion by 2035. 5. Collaboration as a key driver. Reports emphasize the importance of collaboration between public and private sectors in realizing the full potential of space technologies. Initiatives like the Global Space Diplomacy Forum are designed to facilitate dialogue on the economic, humanitarian, and geopolitical aspects of space exploration. Differences in perspectives. While the WEF emphasizes the broad applicability of space technologies across diverse industries, McKinsey focuses on specific use cases in supply chain efficiency and climate change mitigation. Both sources converge on growth projections and the necessity of collaboration. Timeline and future outlook. 2023, space economy valued at $630 billion. 2024, reports underscore the need for collaborative initiatives and investment strategies to enhance the space economy. 2034, anticipated 10% decline in data costs amid rising demand. 2035, projected space economy worth $1.8 trillion. With potential upside to $2.3 trillion based on access to space data and reduced entry costs. Conclusion. The interplay of technological innovation, investment, and international collaboration in the aerospace, robotics, and renewable energy sectors is poised to reshape the economic landscape. Space technologies will lead this evolution, providing a foundation for addressing global challenges and fostering sustainable growth. Stakeholders must actively engage in dialogue and strategic initiatives to unlock the full potential of the burgeoning space economy. Source summaries. 1. Source 1, National Security News. The space economy is projected to soar to $1.8 trillion by 2035, growing at an annual rate of 9%. This growth will be driven by the integration of space technologies across various industries, with a significant focus on supply chain and transportation as well as climate monitoring. Collaboration between public and private sectors is critical for optimizing the potential of space technologies. 2. Source 2, World Economic Forum. Space technologies are expected to revolutionize the global economy, with the space economy reaching $1.8 trillion by 2035. The report highlights the importance of reducing launch costs, increasing satellite launches, and engaging a broader investor base. Applications in disaster management, climate monitoring, and socio-economic development are emphasized as key benefits of the expanding space economy. Implications for stakeholders. The projected growth in the aerospace, robotics, and renewable energy sectors highlights the necessity for stakeholders across industries to adapt and leverage space technologies. Collaborative initiatives, investment in research and development, and strategic planning will be critical for capitalizing on the opportunities presented by the burgeoning space economy. By embracing this transformation, companies and governments can position themselves as leaders in the new economic landscape, ultimately benefiting society as a whole. The projected economic growth in the aerospace, robotics, and renewable energy sectors due to Mars colonization technologies and international collaboration initiatives presents several counterintuitive insights that challenge conventional perceptions about these industries. 1. Transformation beyond traditional sectors. The idea that the space economy will not just bolster aerospace but also significantly impact sectors like agriculture, IT, insurance, and construction might seem contradictory. One might expect aerospace advancements to primarily benefit related industries. However, the reports indicate that space technologies are increasingly integrated into everyday applications, transforming industries in unexpected ways. 2. Cost reduction and increased accessibility. It is often assumed that technological advancement leads to higher costs, especially in complex fields like space exploration. The reports counter this by highlighting that launch costs have decreased tenfold over 2 decades, allowing for more frequent and affordable space missions. This progression leads to an increased number of satellite launches and a corresponding drop in data costs, thereby making space technologies more accessible than ever before. 3. Space tourism as a viable market. The notion that space tourism could emerge as a significant market seems far-fetched to some. Yet projections suggest revenues between $4 to $6 billion by 2035. This indicates a shift in perception, where what was once deemed a whimsical idea is now on track to become a substantial economic contributor. 4. Collaboration over competition. Typically, industries thrive on competition, but this report emphasizes the necessity of collaboration between public and private sectors for the space economy's growth. This perspective suggests that pooling resources and knowledge rather than competing is the key to unlocking the full potential of space technologies, which is contrary to traditional business paradigms. 5. A broader economic impact beyond GDP growth. While high growth rates 9% annually are expected for the space economy, the reports emphasize that the true impact will extend beyond mere financial metrics. The space economy is positioned as a critical tool for addressing global challenges like climate change, disaster management, and humanitarian crises, suggesting that the value of the space economy cannot be measured solely in economic terms. 6. Emerging technologies as catalysts for change. The assumption that emerging technologies will primarily benefit tech-focused sectors is countered by the assertion that they will enable advancements across a diverse range of industries. This suggests a democratization of technology, where innovations in space can lead to improvements in fields as varied as food delivery and retail. 7. Geopolitical dimensions of space cooperation. The focus on international collaboration in space diplomacy may seem secondary to economic growth. However, the reports position these efforts as critical to fostering a stable environment for space exploration and economic prosperity, underscoring the interconnectedness of economic and geopolitical strategies. 8. Investment dynamics. The expectation that public funding would dominate space exploration is challenged by the observation that private sector investments have surged, reaching record highs. This shift indicates a growing recognition of the economic viability of space initiatives, suggesting that private enterprises are becoming key players in an area traditionally associated with government funding. 9. Long-term vision in the face of short-term challenges. The report highlights the potential for space technologies to solve pressing global issues, which may seem optimistic given the current challenges facing the world. Yet it asserts that the long-term benefits of space exploration and technology will outweigh immediate hurdles, presenting a more hopeful outlook on humanity's future. 10. Redefinition of value creation. The traditional view of value creation centers around direct financial returns. However, the report suggests that the space economy will create value through enhanced societal benefits such as improved disaster response capabilities and increased access to education and healthcare, an approach that redefines what it means to create value in the economy. These counterintuitive insights illustrate a shift in how we understand the interconnections between space technologies and global economic growth. They challenge traditional economic frameworks and suggest a more integrated approach to viewing the future of industries influenced by advancements in space. The report on the projected growth of the aerospace, robotics, and renewable energy sectors driven by investments in Mars colonization technologies and international collaboration initiatives contains several important insights that many may overlook. Here are key aspects that deserve greater attention and their significance. 1. Integration of space technologies across industries. The report discusses the transformation of the space economy from a niche market to a critical part of the global economy, with projections indicating that over 60% of the growth will come from industries like supply chain, transportation, food and beverage, and digital communications. While many recognize the potential of space technologies in traditional aerospace, the broader application across various sectors is often underestimated. Significance. This integration signifies a paradigm shift where space technologies become foundational to everyday operations across multiple industries. Companies that fail to recognize this trend may miss the opportunity to innovate and optimize their processes using these technologies, potentially losing competitive advantages. 2. Impact on global challenges. The report highlights that the space economy is not just about economic growth but also about addressing significant global challenges such as climate change, disaster management, and humanitarian issues. While financial projections are commonly discussed, the report stresses that space technologies can enhance disaster response and climate monitoring. Significance. The dual focus on economic growth and social impact is crucial. Stakeholders, including governments and private entities, should consider investments in space as a means to achieve Sustainable Development Goals (SDGs). Ignoring the social implications of space technology could lead to investments that are misaligned with global priorities, undermining efforts to tackle pressing issues. 3. Collaboration between public and private sectors. The importance of collaboration between public and private sectors is emphasized throughout the report. Initiatives like the Global Space Diplomacy Forum are highlighted as platforms for dialogue among various stakeholders. Significance. The success of the space economy hinges on such collaborations. Many stakeholders may overlook the need for these partnerships, leading to fragmented efforts that could stifle innovation and limit the potential benefits of space technologies. A collaborative approach can enhance resource sharing, reduce costs, and foster a more inclusive space economy. 4. Technological advances and accessibility. The report notes that the costs of launching satellites have decreased significantly and the number of satellites launched annually has increased. This trend is expected to continue, leading to more frequent and affordable access to space. Significance. Lower costs and improved access to space present opportunities for new entrants and smaller players to participate in the space economy. This democratization of access can stimulate innovation and lead to disruptive technologies. Stakeholders should pay attention to how these changes can enable smaller companies to enter markets previously dominated by large players, fostering a more competitive landscape. 5. Potential for space tourism. While space tourism has often been viewed as an extravagant and distant dream, the report suggests it could generate revenues of $4 to $6 billion by 2035. This development is significant for the perception of the space economy as a viable investment opportunity. Significance: the emergence of space tourism reflects a shift in public interest and investment in space-related activities. Many may dismiss this sector as a novelty, but it represents a growing market that can drive technological advancements and inspire the next generation of space exploration. Ignoring this trend could lead to missed opportunities for economic growth and innovation in related fields. 6. Long-term economic projections and variability. The report provides a range of projections for the space economy, suggesting that it could reach $1.8 trillion by 2035, with potential upside to $2.3 trillion or downside to $1.4 trillion based on access to space data and technological advancements. And international cooperation. A failure to account for these dynamics could lead to overestimations of market potential and misaligned strategies. 7. Socioeconomic benefits and inequality mitigation. The report discusses how space technology can contribute to reducing inequality by improving access to education, healthcare, and economic opportunities. This aspect is often overshadowed by the focus on economic metrics. Significance: by emphasizing the socioeconomic benefits of space technologies, stakeholders can align their initiatives with broader societal goals. This alignment is essential for garnering public support and ensuring that space ventures contribute positively to global development. Neglecting this aspect could result in a lack of social license for space activities, hindering progress and acceptance. Conclusion: the projected growth of the aerospace, robotics, and renewable energy sectors, bolstered by investments in Mars colonization and international collaboration, presents a transformative opportunity. However, stakeholders must look beyond the surface-level economic projections and recognize the interconnectedness of space technologies with global challenges, industry integration, and social impact. By doing so, they can position themselves to harness the full potential of the burgeoning space economy, driving innovation and addressing critical issues on Earth. 1. Projected economic growth of the space economy. The space economy is expected to grow from $630 billion in 2023 to $1.8 trillion by 2035, reflecting an annual growth rate of approximately 9%. This growth will significantly outpace the global GDP, indicating that the aerospace, robotics, and renewable energy sectors will not only expand but also become increasingly integrated into the global economic framework. This integration will be driven by advancements in space technologies and their applications across various industries. 2. Technological advances and cost reductions. The report highlights a remarkable increase in satellite launches, with a cumulative growth rate of over 50% since 2019. Concurrently, launch costs have decreased tenfold over the past 20 years. This reduction in costs is expected to continue, facilitating more frequent and affordable access to space. The anticipated decrease in data costs by 10% by 2034, coupled with a 60% increase in demand for data, underscores the transformative potential of space technologies on connectivity and efficiency across various sectors. 3. Cross-sectoral impact of space technologies. The influence of space technologies extends beyond traditional aerospace industries into sectors like agriculture, information technology, insurance, and construction. This cross-sectoral impact is essential for addressing global challenges such as climate change and disaster management. The integration of space technologies into daily life, from weather forecasting to logistics, demonstrates the potential for transformative change across multiple industries, making space a pivotal component of future economic strategies. 4. Importance of international collaboration. Collaboration between public and private sectors is emphasized as a critical driver in realizing the potential of space technologies. Initiatives like the Global Space Diplomacy Forum aim to foster dialogue on the humanitarian, economic, and geopolitical dimensions of space. This collaborative approach will be vital in harnessing the collective strengths of diverse stakeholders, ensuring that the burgeoning space economy can address shared global challenges while maximizing economic opportunities. 1. The Apollo Program 1961–1972. The Apollo program was a pivotal initiative by NASA aimed at landing humans on the Moon and bringing them safely back to Earth. Launched in response to the Soviet Union's achievements in space, particularly the launch of Sputnik, Apollo catalyzed significant advancements in aerospace technology, engineering, and international cooperation. The program facilitated extensive collaboration between government agencies and private sector companies, stimulating economic growth in related industries. It is estimated that every dollar invested in the Apollo program returned about $14 in economic benefits, influencing sectors like telecommunications, materials science, and computer technology. 2. The Space Race 1957–1969. The competition between the United States and the Soviet Union for supremacy in space exploration led to groundbreaking technological advancements and economic growth. The launch of Sputnik by the Soviet Union in 1957 marked the beginning of the space race, prompting the U.S. to ramp up its own space initiatives, including the establishment of NASA. This era saw significant investments in research and development, resulting in innovations in aerospace engineering, satellite communications, and robotics. The technological advancements spurred by the space race not only transformed military capabilities but also laid the groundwork for the modern telecommunications and satellite industries. 3. The European Space Agency (ESA) and the International Space Station (ISS). The establishment of the ESA in 1975 and the collaborative effort in developing the ISS, which began construction in 1998, exemplify international cooperation in space exploration. ESA's programs have facilitated advancements in satellite technology, Earth observation, and space science, influencing various sectors including environmental monitoring, agriculture, and disaster management. The ISS serves as a platform for scientific research and technological development, showcasing how collaborative initiatives can lead to economic growth while addressing global challenges. It has fostered partnerships between multiple countries and private companies, enhancing the global space economy and contributing to advancements in robotics and renewable energy technologies. The future outlook for the aerospace, robotics, and renewable energy sectors is exceptionally promising. Driven largely by anticipated economic growth linked to Mars colonization technologies and international collaboration initiatives. By 2035, the space economy is projected to surge to approximately $1.8 trillion, a significant increase from $630 billion in 2023, reflecting a robust average annual growth rate of about 9%. This transformation is expected to reshape not just the space sector but also numerous terrestrial industries, fostering integration and innovation across the global economy. Key drivers of growth. 1. Technological advancements. The aerospace sector is witnessing rapid technological advancements, particularly in satellite deployment and launch capabilities. The annual number of satellites launched has increased at a cumulative annual growth rate of over 50% since 2019, with launch costs plummeting by tenfold over the past 2 decades. This trend is set to continue, enabling more frequent and cost-effective access to space. 2. Integration with other industries. Reports indicate that the impact of the space economy will extend well beyond traditional aerospace applications. Industries such as supply chain management, transportation, agriculture, and digital communications are expected to harness space-based technologies, leading to enhanced efficiency and effectiveness in operations. For instance, satellite technology will improve logistics and supply chains and enhance agricultural monitoring, resulting in better resource management. 3. Investment landscape. Private sector investments in space have reached unprecedented levels, with around $70 billion invested in 2021 and 2022 alone. The interest from both state and non-state actors is likely to continue growing, driven by the potential for lucrative returns and the increasing accessibility of space technologies. Space tourism, once a speculative venture, is projected to generate revenues between $4 to $6 billion by 2035. further highlighting the expanding economic opportunities in this domain. For international collaboration, the future of the space economy is heavily reliant on collaboration between public and private sectors. Initiatives like the Global Space Diplomacy Forum aim to foster dialogue and partnerships that will enhance the strategic development of space capabilities. This collaborative approach is crucial for addressing complex global challenges such as climate change and disaster management, leveraging space technologies for humanitarian purposes. Sector-specific impacts. Aerospace. The aerospace sector will not only benefit from the increasing demand for satellite launches but also from innovations in propulsion and materials technology driven by the need for Mars colonization. This will create new markets for advanced aerospace products and services. Robotics. Robotics will play a pivotal role in space exploration and colonization efforts, with advancements in automation leading to improved operational efficiency in both terrestrial and extraterrestrial environments. The integration of robotics into various industries will enhance productivity and reduce labor costs, further stimulating economic growth. Renewable energy. The renewable energy sector stands to gain significantly from space technologies, particularly in energy generation and management. Innovations such as space-based solar power systems could revolutionize energy provision, offering sustainable solutions to meet growing global energy demands. Challenges and considerations. While the outlook is overwhelmingly positive, several challenges must be addressed to fully realize the potential of the space economy. Ensuring equitable access to space data, reducing entry costs, and fostering a supportive policy environment will be critical. Additionally, there is a need for increased awareness and education regarding space technologies to facilitate widespread adoption, and renewable energy sectors is indicative of a broader economic transformation driven by space technologies. As we move towards 2035, the synergy between technological innovation, investment, and international collaboration will catalyze a new economic landscape. Stakeholders across industries must actively engage in strategic initiatives and dialogues to harness the full potential of the burgeoning space economy, ensuring that its benefits are realized on a global scale. This collaborative and integrated approach will be essential for unlocking the myriad opportunities presented by the evolving space economy, positioning it as a cornerstone of future economic development.